So this is the review of Ratios and Proportions Quiz 2. Maybe you're watching this video because you need to do a retake, or maybe you're watching this video because you're studying for an interim assessment. But either way, we're going to go over the answers here, and hopefully it will be helpful to you. So we'll start at the beginning here. It says this table shows the relationship between the side lengths of a square and its area. So what we're talking about when we say side lengths are this number here, like it might have a length of 4. And of course it's a square, so that means all the side lengths are the same. And it would have an area of 16. So that's what these two numbers are comparing, and it's asking us, are they in a proportional relationship to each other? So is this ratio proportionate to this ratio? And there's a few different ways that we can find out. Right? One way is that we can ask ourselves if there is a common rate between the two terms. Now, in this case, I might ask myself, all right, well, 1 times 1 would give me 1, and 2 times 2 would give me 4, and 3 times 3 would give me 9. It appears there's no common rate here. So that would be a sign that they're not proportionate. Another way that we could check is by looking at the rate of change in the two terms. Let's call this one x and this one y, and we could look for the change in y over the change in x, and if it is constant, we could say that it is proportional, right? So here we see this number here, x's are changing by 1, and each time I move up one column in my table, I'm adding 1 to the side length, right? So I had a 1 by 1 square, and then a 2 by 2 square, and then a 3 by 3 square. That's not a square, my apologies. And then a 4 by 4 square. Each time we're adding 1. Down here, let's see if that change, that appears to be constant. It's changing at the same rate. Let's see what happens down here. In this case, my area goes up by 3. And between these two squares, right, this one was 1 and this one turned out to be 4. Between these two squares, it went up 5, plus 5. So from 4 to 9 was a change of 5. And here, from 9 to 16 was another change of 5. I take that back, that's 7. I got 5 on the brain here, right? So that's a change of 7. So these are not a constant rate. So we have two ways of saying, or two reasons to support the answer of no. And we could say because, we abbreviate it because, there is no constant rate or rate of change. We could say a rate of change. These are really two ways of saying the same thing, right? There's no constant rate of change. So that's question 1. Let's take a peek at some of the others here. That's not good. All right. The graph below, excuse me if you're getting car sick, the graph below shows a relationship between the time spent studying and someone's math grade. And they're asking, does this represent two quantities that are in a proportional relationship to each other? And what we've learned in class is there are 2 tests this has to pass. One is, does it pass a straight line test, right? For example, if my x goes up by 5, I'm going to change colors here. If my x value goes up by 5, does the y value go up by the same amount each time? So it looks like it goes up by 10, right? That's plus 10. Now you might say, how can 5 be, those don't look, the 10 looks smaller than the 5, but that's because the scale on the y-axis is different, right? That's going up by 10s, and this is going up by 5s. So let me write plus 10 here and plus 5 here. All right, now we want to see if that remains constant. So between the next point that I'm going to look at, it goes up another 5. From 5 to 10 is plus 5. And it also looks like the y-axis is increasing from 20 to 30. So it's also going up plus 10. And if we follow this out, we'll see that it is going up at the same rate. That's what causes something to have a straight line. That's the same rate. There is one more criteria that we need to look at, though, and that is, does this pass through 0, 0? And the answer here is yes, right? So we're going to say, yes, they're proportional to each other because, right, it passes through this ratio, or this point on a graph. 0, 0, that's my x and that's my y. and that's not all we need to know, it is a straight line. Another way you can say that is it has a constant rate, right? A constant rate. All right, so that is that question. Let's look at 3, which is very similar. I gotta get better at scanning here, scrolling. All right, this graph shows the relationship between temperatures measured in degrees Celsius and temperatures measured in degrees Fahrenheit. Does this graph represent two quantities that are proportional to each other? And your first instinct might be, yes, they're proportionate. It passes the straight line test. But that is not all, right? You might know that if it is 0 degrees Celsius, right, freezing in Celsius, that equals about 32 degrees in Fahrenheit, and that's what this graph is showing us, right? So that point passes through 0, 32, and that means that there is some other factor involved, and we'll talk about that later. But what happens is it's not just 0, let's make a little table here, is that if x was 0 and I multiplied that by my rate, I wouldn't get my y value. Let me show you what I mean, right? So let's say that the temperature in Celsius is 0. What would I multiply it by to get 32, right? And the answer is nothing. There is no rate that will work to make that 32. Okay, so if there is no rate, right, we could look and say, well, what happens if it is 5 degrees, right? What if it's 5 degrees Celsius? And let's just call this 40 for the sake of argument. Now I can see that there's a rate, right? We could say that's times 8. But the point is that these two things are not the same. 0 times 8 does not make 32. So there's not a constant rate there, whereas there's a rate there. And if I follow this, let's call this one 10 and this 50, right? If I go down one more and say, what if it's 10 degrees Celsius and it makes 50 degrees Fahrenheit, that would be a rate of times 5. And again, it's just proof that it's not the same rate. There is not a constant rate or a direct relationship. So the answer here is no, because there is no constant rate. All right, let's check out the last one here. This test goes by pretty quick if you know what's up. So it says we paid $72 for 12 hamburgers. Write a ratio to represent that statement. That statement is right here. We paid $72 for 12 hamburgers. So I could write that really simply. I'm going to say $72 is 8 hamburgers. I'm just going to abbreviate that with B for burgers. You might remember that Y always goes on top and X always goes on the bottom. Generally speaking, money is always going to be Y. The cost of something always depends on how many of that thing you buy, right? Money always depends. So we put it up on the top there. The dependent variable goes on top. So what is the rate, right? Well, we can remember our formula, Y over X equals the rate. We use a K to represent the rate. So 72 divided by 8 is going to equal $9, right? So $9. And actually, I should leave the unit off of there. It just equals 9. So our rate is going to be 9. And in the next statement, we're going to try and understand what that means. The unit rate for the statement means that I pay $9 for one burger, right? The unit being each thing, $9 per unit, right? In this case, the units we're counting are hamburgers. So one way that I try to help kids remember this is we say the word rate. That's one word. We have a one-number answer. Here it says unit rate. That's 2 words. We're going to have a 2-number answer, right? We're going to have a ratio here. Okay. And if I just got us a 4 out of 4 out of 4 on all the scores here. So if you can do what we've done here on your retake or on your, if you retake the whole thing, or if you see these on your interim assessment, you would have gotten a perfect score. Thanks for listening.